Will you please help me in welcoming Mr. Bob Berman?
Thank you. Thank you for that great introduction, even if I did write it myself. It's great to be, look at that, big letters, time remaining, so I can't blab too much. We're going to really explore something very wild during this next 44 minutes and 36 seconds. And that has to do with the basic questions, probably the most ancient question ever that any 7-year-old would ask, which is, what is this place where that I've been born into? What is the universe? And at one time, the answers were given to us, were entrusted into our priests or spiritual people, or our philosophers, but in the last century or so, it's become the sole province, essentially, in the science world of cosmology. Cosmology is not haircuts and perms. That's cosmetology. And cosmology, you hear all those TV shows about the universe and the Big Bang and all of it, and I keep getting comments that people say, I don't understand what's going on. The answers don't seem satisfying. So we're going to look at that, really, what we know about the universe, why the answers aren't satisfying, and where they go wrong. We've heard Neil deGrasse Tyson on the new Cosmo show. You know, I'd love to see him in the ring with Mike Tyson. Remember that heavyweight champion? That would be a great fight, because Mike Tyson has become a really religious guy, and Neil deGrasse Tyson goes around the country. He's really a fervent, strident atheist. It'd be great to have them in the ring. You go away and you say, I don't understand that. Part of the reason is that some of the things that are said, like the Big Bang, everything happened 13.8 billion years ago. They said 13.7 just a few years ago. Now it's more precisely fine-tuned, which is great. And we use real science, excuse me, to get to this data. The flat topology of space, which we're going to talk about in a moment. The baryon acoustic oscillations, which essentially is how sound waves propagated through the early universe. The ratio of type 1a supernovae, the flux of those compared to redshift. The Hubble constant. The cosmic microwave background, that 2.73 degree warm toasty radiation that comes from all parts of the sky. Well, it has a certain anisotropy angular power spectrum. That tells us a lot. The deuterium abundance. There's a lot of hard, fast data, and yet it's not giving us satisfying answers. One of them is that the stuff doesn't make sense because it can't make sense. There's 4 real reasons. I'm going to give you all 4 why this stuff doesn't work and what we have to do about it. The first is the absence of a lot of data. I've just given you the procedures we use, and yet you know that most of the universe is dark energy, 74% of that. We have no idea what that is. Most of the rest is dark matter, and we don't know what that is either. So it leaves 4% made up of the 92 natural elements and all the subatomic particles, but we only know about those in our vicinity, because as we look far and far away, we know less and less. For example, here we're showing you space, traveling through space. We're going to see in a little bit that space actually is not real. And we have an image, all of us, of the universe in a space and time framework. The Big Bang happened a certain long time ago. Galaxies are separated from us by space. So when we look at and see that space and time may have a questionable reality that pulls it out from under us. But worse than that, the Big Bang was an explosion where the whole universe got created out of nothingness. Now, that doesn't compute with us partly because in our own everyday life, we don't see puppies and lawn furniture popping out of nothingness. A universe popping out of true nothingness, how can that be? And even if we figured out how it could be, what are the antecedent conditions that produce this Big Bang? They'd only be guesswork. How could we possibly know what things were like before the universe was the size of a grape? And if we did know that, then we'd still arrive at a question of where did that begin? What produced that? So we're set up with an infinite regression of questions that even if we pin down the Big Bang exactly, we can't get to the answer of those. So part of it is a matter of data. For example, on the moon, we just found out in the last week that the moon has water on it. Well, we've been studying the moon. We've been there first. The first Russian spacecraft passing it was in October of '59. So we're talking about half century. It took us this long to find out there's water on Mars, but we've found out recently that there's ice also on the moon. So we're just still learning about these things. And when it comes to distant galaxies, the information is a little sparse. So the data is limited. Plus, we're working on the assumption that studying the parts will give us the whole. Now, it may or may not be true. If somebody studied you and determined exactly what your composition was, you're mostly oxygen, by the way, as is all, life forms. So is the moon. Actually, when you get coyotes howling at the moon, it's really oxygen howling at oxygen, is basically what's going on. But even if someone exactly analyzed what you were made of, would they really know who you are? Can we really get the whole from the parts? Sometimes not really. Those of you into chemistry know that if you studied sodium thoroughly, knew its boiling point, melting point, everything about it, knew how hydroantagonistic it is, you throw a piece of sodium in a brook and just about explodes. Or chlorine, one of the most deadly substances, the main component of those gases in World War I, those horrible gases. No one could have figured out ahead of time that putting them together produces NaCl, sodium chloride, salt. Not only does it not explode when it hits water, but it dissolves harmlessly in it. The water stays just as unruffled and invisible as before. Not only is it not a poison, but it's vital to life, unlike chlorine, its component chlorine, that you couldn't live without sodium chloride. You could not have figured what you'd have by combining the parts. And yet in cosmology, we have to study the parts. We don't know what the whole thing is. So it may or may not result in something helpful. But the worst is the lack of data. For example, we are recently finding, and this is just 2 years ago, a team at Berkeley studying 900,000 galaxies found that space has a perfectly flat topology. That is, space-time does not curve. Now, everything that weighs anything causes some curvature. You know about round black holes or dense galaxies, that images can actually warp around them. So the whole universe, which weighs quite a lot, should start showing a large-scale curvature. So this study, the largest ever, shows that it does not in the least, which indicates that at minimum the universe is tens of thousand times larger than anything we can see to the edge of the observable universe. But most cosmologists are now leaning toward the universe being infinite in extent. You can't ever prove infinity, but that's the way it's going, towards an infinite universe. But there's a problem with that, because if the universe is infinite, then everything we can sample, we've already seen that because most of the universe is dark energy and dark matter, and we have a very little sample size. But if the universe is infinite, that means everything we could ever possibly look at, observe, is not just a little tiny fraction of the whole universe. No, any fraction of infinity is zero. So 0% of the universe is ours to sample. I don't have to tell you how reliable such a sample size is. So that's our first issue when we see these cosmology shows, and the reason they're not getting anywhere is just a lack of data. Now, We make up for it with models. We're very model-driven. Like we say that 380,000 years after the Big Bang, the universe stopped being opaque, and that's when electromagnetic radiation could radiate through. The cosmic microwave background comes from that moment. But even if that's the case, it still doesn't lead to ultimate answers. We have a model that's the way it works. It may not be the case. And that's not a problem as long as people realize that these are just starter models and that they do change and will change in the course of our lifetimes. All right, the issue number 2 is the limits, and this is a little wilder because they really don't talk about that, of our dualistic logical mind system. And that is, what I'm going to do is tie my shoelaces here so I don't fall on the stage. Getting a laugh is good, but not that kind of laugh. What I'm saying is that there's 2 types of ways that we get information. One is direct, like if we touch a hot frying pan, that's direct. The other is indirect, if someone tells us watch out for that hot frying pan. The word water is not actual water. The way our minds work, the way our logic works, is through symbols for things, representational. In some cases, that's fine. In science, it's fine. In some cases, it won't work. Unless you experienced love, let's say, you would not know what it was. And if you had been born blind, you could not know when somebody talked about the color blue, what they were referring to. You have to have experience with the thing that the symbol represents. And when it comes to the universe at large, we run out of symbols. We don't have pictures for that. We've already seen that in the quantum realm of the very tiny, our logical system doesn't work. This is famously true. Famous physicists now for 30, 40 years, Feynman and others, have been telling us you cannot understand quantum theory. And the reason is that our logic doesn't work for it. Let me give you an example. If we're discussing your cat and its relationship to your kitchen, we could say that your cat at this moment is either in the kitchen or not in the kitchen. Or maybe also partly in the kitchen if it's sleeping in a doorway or something. But those are the only 3 choices. Can you think of any others? In the kitchen, or not in the kitchen, or partially in the kitchen. But when it comes to the land of the very tiny, things go beyond our choices. For example, an electron can be created. Old TV sets used to create electrons. We beam them toward a detector. And on the way, there's a series of the equivalent of mirrors that can make them either take path A or path B. So we have detectors that show us that the electron arrived, but it did not take path A. It did not take path B. It did not take neither path, because if we block them both, it never arrives. And it didn't somehow split itself off and take both paths simultaneously. Now, those are the only choices. A, B, both, or neither. Did something else. Now, we have a name for it, for these impossible feats of non-logic. We say that the electron was in a state of superposition. But just naming it doesn't mean that it makes sense logically. It doesn't. And there's growing evidence that the meta-universe, cosmology, this whole thing, topic of this talk, is the same way. That our logic system just might not work with it. We've already seen that with the Big Bang. It doesn't, because any answer that we have only leads to more questions. There's never a solution to the birth of the universe. How is the universe born? Because there's something before that. We could say maybe it's eternal, which is probably true. But nobody can visualize eternity. I'm asked a lot, all astronomers are, about what is the universe, since it's expanding, what is it expanding into? And my pat answer, I used to do this when I taught college astronomy, when I was lazy, I would just say, the problem is you've set up a non-existent vantage point. To imagine the universe expanding, you've imagined yourself, visualized it as if you were outside of it. and that the whole universe is like a balloon getting larger. But there is no location outside the universe. So it can't be seen as expanding into something else. Rather, the way to picture it is, imagine yourself in any cluster of galaxies, and you'd see the space between yours and all the others growing larger. And everyone can picture that. But that's still a cop-out, because the universe is growing larger, and it's fair enough to say, well, what does that mean? And we can't picture that. We'd say, what is it expanding into? And then what's outside of that? If the universe is infinite, we can't picture infinity either. Plus, infinite in size also means that the Big Bang could not have been the start of anything, because you can't get an infinite universe, infinitely sized universe, from a finite starting point. So that means the Big Bang was just a local event in the hood. And that the universe we're talking about is really the observable universe, and there's an almost infinitely larger stuff beyond it. Also, if the amount of material in each cubic light year of the universe is the same everywhere, as we think it is, that means the stars and the galaxies and the planets go on and on without end either. Can any of us picture limitless stars and galaxies without an end? Can't do that with our minds, with our representative, symbolic, logical, word-based thinking process. We can't grasp infinity, we can't grasp galaxies without end, we can't grasp a beginning. So what I'm saying is that all these things, even though cosmology is trying to pin down the moment of the Big Bang, that's not answering the fundamental questions that we want to answer. We want to understand this thing, and it's not going to help us understand it. You don't hear this on the TV shows. The third is, this one is a real hard one, is space and time. I mentioned it before when we looked at this, is that time we've always known. I think most of you would agree that time doesn't really exist. Very few physicists think it's a real thing. It's true that we say the sun was created 4.5 billion years ago or so. Here's an old book about the sun, written a long time ago. What did we know about the sun back then? Almost nothing. Here in chapter 1, it says it's hot. That's all we knew. Sun is hot. Newton's laws, Einstein's field equations, quantum mechanics, none of them have a place for time. Time has no role, because time is not really believed to be an actual item. There's a lot of disagreement about that. Newton thought it was. Other smart people like Immanuel Kant said, no, it's not. It's something that our minds create as an ordering system. Now we know that we have avalanches of electrical activity in the brain, and we're trying to make sense of it all. And we do observe change, but change is not the same thing as time. It's true we could say that a candle burns down 1 inch, and at the same time the Earth rotates 1/24th of a turn. We use vibrations in the nucleus of the cesium-133 atom to define a second. We say if you shoot microwaves out at a certain number per second, it'll maintain this state, not flip over to another state, the hyperfine state. Those of you who are real geeks have that number memorized. How many of you have the number of the definition of a second memorized? Let me just see if there's anybody in here. Raise your hand. I've got to see it. Nobody. All right. 9,192,631,770 vibrations per second. That's how we define a second. But does that mean that a second is a real thing, like a cucumber that you can grab and take to a lab? No, time is a ordering system, something that we animals create. We carry it around with us, like turtles with shells. And space is the same thing, plus it changes its rate. Time does. Einstein told us this, that if you travel at a faster speed, time will slow down. If you go into a stronger gravitational field, time slows down. So some events will continue to occur at a certain rate while others occur at a slower rate. We see this all the time. Each one of you has 240 muons tearing through your bodies every second, and they're not always harmless if one strikes the wrong bit of genetic material in one of your cells. Those muons theoretically should not get here. They're only created 35 miles up when cosmic rays hit high up atoms in our atmosphere. They only live for 2 millionths of a second. And that's not long enough, even though they travel near the speed of light. That's not enough time for them to make it all the way down, 35 miles to the surface and through your bodies. They do so only because their time is now running so slowly relative to you, thanks to their high speed. So this isn't theory, this is fact. More surprisingly, it's the same thing with space. We might think of space as some absolute thing, and the gap between us and the Andromeda galaxy as being inviolable, but it isn't. First of all, space isn't even empty. We've known now for a long time that it has fields, magnetic, electrical fields, that photons zoom through it. There's 1 billion photons for every neutrino. That's the next most prevalent particle in the universe. And since light and mass, energy and mass have an equivalence, it means this light means that space isn't really empty. But worse than that, since 1948, we've known about vacuum energy. That the seemingly empty space between you and me here seethes with almost unimaginable power. Sometimes it's called Z-point energy, zero-point energy, because it starts showing itself when all other energies have been brought to a standstill. There really is only one other kind of energy we now know. We used to think it was frictional energy and chemical energy and gravitational potential energy, but now we know it's all kinetic energy, the energy of motion. And atoms, when they move, we have a word for it. It's called heat. So all you have to do is slow down atoms, in other words, cool things, until there's no more of that kind of energy, and then you reach equilibrium with this ultra-powerful but invisible vacuum energy or zero-point energy. At 459.67 degrees below 0 Fahrenheit, 0 degrees Kelvin, that's when all motion stops. And that's when you start to see the signs of this all-pervasive energy. And it's powerful. It's been estimated, well, the estimates are all over the place, but one estimate is that each empty mayonnaise jar of empty space has enough power to boil away the Pacific Ocean in 1 second. And you still wouldn't use it up because adjacent empty space would rush in. Why can't we see it? We've not been designed to see it. And by designed, I'm not using any spiritual thing, just let's say structured. Why should we? How would it help us if we're looking for our socks in the morning or something? To see this omnipresent, unbelievably powerful energy that's equally everywhere. That would just be distraction if we could perceive it. But it's here, it fills all space. So empty space is not empty. Secondly, what we call gaps or space are often a function of just our own language. We divide things according to color or shape or utility. Waterfall, where does it end? Do you count the mist in or out? How about the sun? Is that empty space? We wouldn't say so. We'd say that's a body, but it's almost all empty space within its atoms, between its atoms. Almost all empty space. The whole human race. If you took away all the empty space and all of us, almost 8 billion people, you'd be left with a sugar cube of actual solid material. Sugar cube. It's a whole human race. Drop it in a cup of tea. And the next reason has to do with this Einstein thing. I talked about time, but with space, it's the same thing. The faster you travel, space shrinks. There's no absolute space or gap between anything and anything else. He told us that a whole century ago. And countless experiments have shown that it's true. If you could travel at 99.9999999, 7 nines after the decimal point, percent of the speed of light, which is allowable, this entire room would now only be a 20th of an inch. across. And you wouldn't notice anything amiss, because you too would be smaller. So there's no absolute size. Same thing was true of time changing. Stephen Hawking used to think that there was an arrow to time, a directionality to events. He said that if the universe ever stops expanding and starts contracting, the arrow will reverse itself. But then later he changed his mind, as if to demonstrate the process. Then, maybe the worst of all is the finding of EPR correlations, or particle entanglement, which means that two objects that are created at the same time know what each other is doing. Now you can do this, for example, by shining a pulse, a photon of light into certain crystals like beta borium borate, and then what you get is two photons come out, each with double the wavelength or half the energy, so there's no gain or loss of energy. They each fly along separately for as far as they want, but they're each aware of each other. And this entanglement isn't necessarily light. That was first done in 1998 in Switzerland, but can be solid particles also. Electrons are even more substantial things than that. But here's the thing. John Bell showed us in the 1960s that objects don't really have an existence until they're observed. This is going to tie in with our next aspect of reality, which is consciousness. That only upon observation is an electron in a particular place. Until it's observed, it's in kind of a blurry, probabilistic state. We used to think electrons, yeah, they're going around an atomic nucleus. Now we know they're nowhere until they're observed. The observation is their reality. So you observe one of these entangled particles and it snaps into existence. Its wave function collapses. That's how John Bell would have described it. And it becomes an actual particle with some quality, let's say an upspin. Well, instantaneously, its entangled twin, even if it's halfway across the universe, knows that you made this observation, knows that its twin was observed and became an actual particle, and in real time, no delay for the information to get there, becomes a particle of its own with a complementary property, a downspin in this case. We've done experiments now since 1998 showing that this is true. National Institute of Science and Technology, we've done experiments over and over. So particle entanglement is true. The point is that if objects here can know and respond to an object 3 billion light years away in another galaxy in real time, simultaneously, no delay, it means that there is contact between everything and everything else in some sense, in some real sense in the universe. So that's yet another way in which there's no real space or emptiness or gap. Okay, did we get that all? There's the particle entanglement. There's Einstein showing us that gaps change according to circumstances. We saw that empty space isn't empty. So for all these reasons, space isn't really a real thing. The relevance to this conversation is that it means that when we picture the universe, all of us do this, we visualize the cosmos here, where we are, in a space and time framework. We picture the galaxy separated by distances and time played a role. Now, knowing that they're not real, they only have relative reality. They seem real because we all went to high school where everyone hung out in the same gravitational field. And nobody drove their sports car faster than like 1/6 millionth of the speed of light. But if we had, we'd have seen different objects going at different rates and different gaps between the universe, and we'd know that all of this was true. So we can't picture the universe. If we really want to get a nice, meaty handle on what it is, we have to give up the space and time thing. These are just tools of animal perception. There's no such things. So that visualization doesn't work. We've already seen that infinity, birth of the universe, what is it expanding into, infinite mass and matter, that doesn't jibe with our logical system. And now we're seeing other ways in which it doesn't work as well. Now we introduce the strangest of all, but perhaps the most important, consciousness. My friend Paul Hoffman, former publisher of the Encyclopedia Britannica, I'm only showing him off by mentioning him just to show you that he's a smart guy. And a no-nonsense guy. I live not too far from Woodstock, New York, so a lot of some of this hippie stuff, you'll hear that from me. He doesn't have a New Age bone in his body, and he's an atheist besides. And yet he says that consciousness is the greatest unsolved problem in all of science. Because you see, everything we experience, we are seeing, we're thinking, we're concluding. It's all taking place on the window screen of awareness or perception or consciousness, obviously. And we've known now since the 1930s, early 1930s, that experiments go differently depending upon if we measure them and how we measure them. The double slit experiment, I won't get into that here, but look it up and you'll see that how we decide to measure something, where we measure it, makes electrons or atoms or photons turn into waves or particles. They'll materialize in different places depending on us as observers. That's why John Wheeler, Nobel physicist, late John Wheeler, just died a few years ago, liked to say that no phenomenon is a real phenomenon until it's an observed phenomenon. So consciousness is bound up with the universe. We want very much to know what this is. And understanding cosmology, remember, that's what the talk is about, trying to figure out what and where is this place that we are. We can't ignore the fact of us as observers. Some people don't really get the profundity of consciousness. They say, well, it's just some chemical thing in the brain that makes us see and hear. What's the big deal? But it's very, very deep and vital to all of this. Not to mention that it's very possible that the universe is correlative with consciousness. In other words, when we're talking about the universe as a whole, we are talking about consciousness. The two don't exist side by side. I know the current view is that the universe existed for perhaps billions of lifeless years, but then you have a problem. You got these little insensate, dumb as gravel, actually there was gravel, slamming into each other, pieces of carbon and hydrogen, bam, 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 and somehow they became that skinny guy who always wins the hot dog eating contest. How does dumb hydrogen and carbon slamming into each other forever develop a sense of smell, the smell of a new mown lawn or a rapture at seeing the purples of a twilight sky? How do you go from just being dumb and random, carbon, gravel, oxygen, to having consciousness and awareness? How does it start? We don't even know where to begin with that one. We can map different areas of the brain that control different functions. That's the farthest we've gotten, but that doesn't explain the experience of thinking. Forget about how we think. We want to know, what is that experience of thinking like? Why have that experience? How does the universe experience itself? How did that begin? We don't even know how consciousness enters a fetus. The Hindus say it's at the 3rd month of pregnancy. How do they know? We don't know how it began collectively on Earth or maybe any other places, and we certainly don't know if there is such a thing as the universe existing absent it. All we know is that our awareness and perception, this is more and more obvious to physicists, are bound up with it. There is no real reality unless it's an observed reality. So consciousness is very, very important. One of the ways we can make it clearer is maybe with light, because that's an aspect of it. These are the colors that every star, including our sun, produces. It wasn't long ago that people believed that if everyone left this auditorium, those colors would still be there. Now we know, of course, that light is a wave of magnetism, and at right angles to it, a wave of electricity. Nobody can see magnetism, and you can't see electricity. So by itself, what's there are electricity and magnetism, nothing with color, nothing with brightness. The brightness and the color you create. It can't be there. And there's all sorts of oddities with it too. For example, the way the structure works is, you might think there's three universes. First is the external world where you see those colors on that screen. Then they go into your eye and form two images on those 6 million cone-shaped cells that give us color vision. Then those produce electrical signals that go up heavy-duty cables to the brain, mostly the occipital lobe, where tens of billions of cells and 1 trillion synapses. This is heavy-duty stuff. Nature doesn't do anything for no reason, and this is a lot of investment in that. Creates the actual image. Every textbook will tell you that that is where it's created, and that is where it is perceived. Again, George Berkeley, for whom the campus and town were named, liked to say that the only things we can ever perceive are our perceptions. We only assume there's an external universe that corresponds with them. So I just named 3 different visual worlds. There's the external world out there, which you all assume is not in your body, but some distance from it. There's the 2 images upside down on the back of your brain, and then there is the third one, the place where the image is created and perceived, and the colors are created in the brain, in the mind. 3 different visual worlds. And yet you're not seeing double, let alone triple. You're seeing one visual world. So which is it? Where is the universe? Is that the external world? They tell us now, hey, just read Dr. Roy Bishop, prominent physicist in Canada, writes in the Canadian Astronomical Handbook. Isaac Newton said they are not in the external world. He wrote a paper called "The Rays Are Not Colored." So it's been known for a long time. And there's also sorts of vagaries. For example, yellow light may not even exist, created by us when we see a combination of green and red. See this yellow light? If I shake it at the right speed, you may be able to see the component red and green that makes up. Can you see that? That is actually creating it. You're creating that in your mind, this yellow. So it seems like we're getting to saying that that's the inside of your mind, that your brain is not really that dark, wet, mushy place, but it's that. Can't be. You're saying, no, now here's my body. My body ends with my fingertips. No, that's your body's image within your mind. Your mind has produced a body mind. You rub your hands together. You can even do it now. And you'll feel something that, of course, is occurring in your mind. Otherwise, you wouldn't experience it, would you? You're seeing your fingertips. That image is also occurring in your mind. It's the image of your body within your mind. The image of these colors are also within your mind. They're no farther away, really, than your fingertips. They're both equally inside your mind, inside your brain. That's true that if you wanted to walk to that screen, it would take you a little time to do it for your body mind. The body within your mind, or we could say mind-body, to reach the mind screen. And then you could say, well, that's the gap. I'll define that as the gap, how long it takes this. But understand that you're walking through your own mind the whole time. I know, Woodstock and all the rest. And I'm going to... But I tell you, this is all true. We can't quickly get it because we spend a lifetime of imagining that everything we see visually is occurring in front of our noses in some external world. We call it the external world. But if that wasn't your mind, you wouldn't be experiencing it. That's the only place colors occur. But even if you don't accept all of that, certainly accept that consciousness and the universe go together in some way, that if we have not grasped that, we have not really gotten the picture. And so for all these reasons, when you hear the TV cosmology shows, they are unsatisfactory. They do not yield any results that feel good. They can't. So we need to go in a different direction if we're really going to solve these things. Hopefully there'll be more studies of consciousness. Perhaps we'll find ways of accessing the universe more directly than the ways we are. Oh, and with the space thing not being real, the takeaway I want you to have from that is that the universe is not huge. Yes, compared to the little mind body that's being presented in your mind, yeah, that seems bigger than you. But because there is no absolute distance, and because things are actually in touch with everything else, a much better way to think of it is that the universe is actually sizeless. That's the truth. It's sizeless. And when you hear the TV science shows, don't assume that they're smart, you're not, that's why it doesn't make sense to you. Truth is, most of them are not even aware of these things, these four main factors that I've given you, which is why you cannot get answers at this point with them. Because I might just forget to mention it, the book Zoom, I love this because it's the first time I've written 9 books, and the New York Times finally woke up to my existence this year by writing a nice half-page review, a rave review. So just to let you know, that book is not about this stuff. It's not about this mind-twisting stuff. It's about motion of all types. The poles shifting. You know that the magnetic poles have moved the length of the stage while I've been here? And it's been doing this for decades. What does that really mean? I had to spend a year of research learning all sorts of cool stuff. I didn't know that snowflakes, 85% of them, form around a living germ. So that there's a bacterium, a living one inside it, 85% of all snowflakes. I didn't know germs could travel 20 times faster than fish relative to their size, so that bacteria can swim across a kitchen counter in an hour. And all sorts of stuff. So it's all different areas of motion, natural motion, deserts and wind. The first guy who taught us how the wind blows, why the wind blows. So it's all solid science. Amazing science, I think, not this stuff. This talk was really designed to be a supplement to that. Because in that I couldn't get into, we got into the parts of the universe in that, not the universe as a whole. And we all want to know what this is that we've been born into. So what's the answer? Where can we go with this? Hopefully, there are ways. If our thought process, just like with the quantum world, doesn't really work with the macro universe, the universe at large, if it always yields puzzles, any process that always produces an unsatisfactory answer means you're asking the wrong questions, or you're using the wrong process. And this is always producing answers that make no sense. Infinity, a universe popping out of nothingness, and the rest. And it doesn't mean that we can't understand it. We are representatives of the universe. We didn't just get here from somewhere else. We have the universe inside of us. So it may be that those who look at it maybe in a more simple way. William Blake in 1803 talking about seeing the universe in a blade of grass. Understanding everything in a grain of sand. It could be that the secret might lie in seeing that the thing we're looking for is obvious rather than hidden, and present rather than absent. 18 seconds. All right, thank you. Thank you, everybody. Thank you. Thank you.
I have a very serious question to start off with. What the hell are you talking about? And I'm really sorry I slept through science in high school. I mean, so let me start out by saying, you say, I said Bob spoke 4 or 5 years ago, as well. You can see why we brought it back. Tell me a little bit more, try to explain a little bit more from my feeble mind, when you say the universe is sizeless.
Well, the universe has to be sizeless if the gap between anything and anything else mutates according to any number of parameters will make it change.
Okay.
And if there's no real separation between anything and anything else, which is the way quantum theory has already showed us, then there's no absolute size. Sure, we can say that from our perspective, in this gravitational field, traveling at this speed, we measure the farthest visible galaxies to be some 13 billion light years away. That's valid. We can say the distance to the nearest star is 4.3 light years. That's valid. But that's only valid as long as we define the parameters in this gravitational field traveling at this speed. If you're really talking about the actual reality, and that's what we're talking about here, no, there's no real size.
Is that influenced, but is that influenced anywhere by, at least, I guess, and I guess in a sense what you're saying also is the speed of light is something that is a part of our gravitational experience? I mean, because we know we know that it takes 10 light years to get to X. Is there, if that was not a boundary, if we could go faster than the speed of light.
You can't go faster than the speed of light, but you can experience different things depending upon how close to light speed you get. When you shine a flashlight beam out your window, from the moment you've turned that flashlight on, each photon experiences itself already reaching the edges of the universe. There is no passage of time for a photon, and there wouldn't be for someone traveling at that speed. And even if you kept it legal and traveled just under the speed of light, you'd essentially find yourself everywhere in the universe at once. There'd be no gap between you and anything else. So where would distance be? And that's not theory. This is not Woodstock. That's the fact of it.
I'm sure glad I drink. Go ahead. Yes, sir.
Well, it's good to know that sizeless matters, but I think that I am
Can you introduce yourself, please?
Oh, I'm sorry, David Bybee. I think that I'm conscious, and I perceive you sitting there, and I also think that you are conscious and perceive me, but I'm coming to the concept that maybe there's only one consciousness.
Very good, very good. Nobel Prize winners, at least one, said exactly that consciousness is always singular, and the plural is unknown. But then we start getting over into solipsism, and that's a whole other thing. So there's two different realms, and you can't really blur them. One is the direct experience, and the other is the conceptual or representational or symbolic world, where salt, we say pass the salt, everyone knows what we're talking about, even though the word salt is not actual salt. So you can't blur between the levels. If you have direct experience, then perhaps you get this, you get it. But as long as you're in the kind of conceptual realm, then it's cheating, and it doesn't work if you try to sort of use that but say the other stuff. It's one or the other.
What about the notion that I think some people, the consciousness is in fact everywhere universal, and we are simply receptacles for that or part of that? Do you have any sense of that? I mean, does that resonate with you?
Right. Once we define who the we is, exactly, okay. Yes.
Okay. Yes, sir.
Amir Kucharski, University of Kentucky. Thanks for coming out. Great talk.
Did you understand it?
I understood a little bit of it, not as much as I would have liked to, unfortunately, which is why I'm here to ask questions. Two probably pretty quick ones. You mentioned time not necessarily being an absolute, and I don't see any necessarily direct problem with that, but what about time-dependent solutions to, say, the Schrodinger equation, or more specifically, these fundamental constants that are time dependent, for instance, Planck's constant. So how does that factor into,
What fundamental constant is time dependent?
or not necessarily fundamental, but
Because there
like-
are no fundamental
right.
constants that are time dependent.
When I say fundamental, I mean things that we are using in very basic models of science,
I
like
mean, like timing an egg so it doesn't get too well done.
perhaps, or like Planck's constant.
Well, of course, in the relative world, of course we use it. The GPS tells us that if we stay on a particular road, we're going to reach Indy in 2 hours, and we do. So, you know, it works as a relative concept. The question is whether it's a tool of our perception or whether it's an actual item. Now, if it's an actual reality, dimension, that's one thing. But if it isn't, then it certainly can't be measured on its own. You certainly can't travel through time if it's not a dimension of its own, if it's only a tool of our perception. And that's the way physics is going. That, like our numbering system, it's like that. It's the way we think and order things.
So does science simply, do you think science is perhaps more of just a model for what our consciousness may observe and perceive, and less so a set of objective truisms about the universe?
Science generally ignores consciousness because it sounds weird. It probably sounded weird to many of you in the sciences because we so don't understand it, not just how it arose, but what it is, that what we do quite properly in science, when we don't understand something, we leave it alone. And so that's what we do. We leave it alone so much that if it comes up, as it did here, it sounds new agey or strange.
Thank you.
Yes, sir.
Hi, I'm Jason Clark. Actually, your answer to this last question is kind of leads into mine. Yesterday, there was a really fun interaction with Dr. Roman Yapolsky.
There's Roman again.
Is that it? So he, working in artificial intelligence, his assertion was that there is no scientific proof for the existence of consciousness. So the question about self-aware machines is a moot point because we can't prove that we're conscious. So do you want to, I guess, what's your position
If you want
there?
me to tell you that you're conscious, that you're experiencing consciousness, then, you know, if you don't perceive consciousness, if you don't think that you hear and see and experience, if that's not self-evident, then there's nothing I can add to it.
So even if we're deluding ourselves to think we're conscious, that's proof of consciousness.
You may be overthinking this.
Yes, sir.
Gary from Louisville. I'm still trying to understand one of your first statements about an infinite universe. Can you give me a concrete example of what that is?
What that is, explaining infinity can't really be explained. However, if this holds up, and it appears to, that there's a perfectly flat topology, it means that the universe keeps going and there's no boundary. So we used to think that there's essentially a positive curvature to things, but there's no trace of it. If the universe is infinite in spatial extent, then it's also infinite in inventory. That's an assumption, but we assume that would be the case. And you're back with, you know, good luck picturing that, if you can. I can't.
You know John Barrow, the cosmologist, written several books. John spoke, I think, back around 2007 here, and he wrote a book on infinity, and one of the things in his book of just reaction said, if in fact we live in an infinite universe, that means anything that can happen is happening infinitely somewhere.
Right. Again, that's maybe, that's a line of thinking that if there, you know, there are some that think that, of course we need it in math, infinity. It's required in math, but is there such a thing as a physical infinity? Does it exist in the physical universe? And many are thinking it doesn't. Certainly it comes up in the singularities and black holes where things may collapse to infinite density. But what does it mean for things to be infinitely dense and occupy no volume of space at all? Does that really have meaning? So it could be that other forces, in this case perhaps the strong force, steps in to prevent infinity from happening. However, the alternative to infinity still leaves us with insuperable questions, unfortunately.
Yes, sir.
Jim Welch at Brown Forman. I'm looking forward to having one of our products shortly where I'm sure it'll make this become a lot clearer to me. We're in the wine and spirits business. Anyway, so one of the last sentences you said was, that doesn't mean that we can't understand it, meaning the universe. When actually my takeaway from your whole talk is that it will be impossible for us to understand the universe because we are fundamentally limited by all the things that you're creating. And anything that we might come up with to explain it is, of course, a human construct and therefore can't be true. Am I missing something?
No, I'd agree with you that as long as we use this one word at a time conceptual realm where things stand for other things, for the four main reasons that I gave, that's not working to really grab hold of what this thing is, what this universe is. However, I did mention, this is a science talk, so I don't want to get into mysticism, but perhaps there are direct ways of perceiving where one can fully grasp the universe, but not through logical symbolism. I'm offering that because I don't want to end on a gloomy note and say it's impossible. And there's certainly been mystics through the ages that have come away smiling and say, oh, yeah, I've got it. This place is okay. I mean, it kind of feels like it's okay, doesn't it?
Actually, I think that's the most hopeful thing you've said today, actually. No, seriously. I think that's great. Yeah, thank
But
you.
isn't it like, I mean, I think what you're saying, and I agree with this, I mean, that's why our imaginations become so important. It's almost being able to use our imagination to suspend, to the extent that we can, the preconceptions and assumptions that we have. I mean, Einstein did that, right? Thought experiments. I mean, scientists do all that time. You know, Einstein, a lot of his big discoveries were thought experiments. The math came later. I mean, he didn't sit down and say, let me figure this out. He basically suspended and said, wait, I wonder what it would look like if this happened. So I think what you're saying, I do think in that sense, we are capable of trying to find the answers by using using one tool we do have, which is imagination.
Right, right. Or futility needn't be depressing either. You know, the ancient Greeks, when they'd come upon something they couldn't answer, they would just have another glass of wine and they'd laugh.
Yeah.
You know, it didn't bother them.
I get that. Yes, sir.
Hi, I'm Jens Heinemann. I teach computer science at Kentucky State University. And so our fundamental models that we make, and I understand the difference between model and reality, are still based on, if you look at the Schrödinger equation, that's continuous in space and time, yet when we collapse the wave function, we end up at something that's discrete. What, if anything, would change if we ever find out, real or not, in our models, that we have to treat space and or time as discrete as well itself?
Well, we do. I think we're already there where we have to. Even when Einstein created space-time, showing that space and time did not have a separate reality. Again, that's why this stuff is not new. When I tell you that space doesn't really exist as a real item, and neither does time, Einstein said this a century ago. But he wasn't saying that space-time is a real thing either, like a three-dimensional graph paper as a matrix that everything exists in. It was merely a mathematical way of explaining motion that would otherwise be contradictory and wouldn't make sense. So it was really explaining, as you know, how different reference frames perceive the same phenomena. It wasn't meant to be putting out a new type of reality to replace the old.
We have time for one more question. Yes, sir. Let me Bob's going to be here the rest of the day. He's doing an Ideas Night Out tonight. Some of you want to sign up for his dinner, so go ahead.
Grayson Salyers, Boyd County High School. What is your take on parallel universes or universes you created when you make a decision? Like
Oh, that one that you said about making a decision, that's a little tougher. That's a spin-off of the many worlds interpretation of quantum mechanics, which is that every time a leaf falls here and not there, it becomes part of a whole universe where that happened and the consequences happen. If you turn left at a traffic light instead of right, you continue on with your decision, but another you immediately exists that's unaware of the first you that goes on in a universe that makes those. That's one type of parallel universe that never smelled right to me, frankly. It just doesn't. Now,
But parallel universes could exist in an infinite universe, what you're talking about.
one type of universe, no doubt, exists. One type of parallel universe, and that is the one that we can't see. So
Yeah.
beyond where objects are receding at the speed of light, there's more stuff. Our universe doesn't end, and so if you call that another universe, we'll go along with that. Unfortunately, there's a whole host of new universes, some of them based on string theory, which has now proven to be a failed theory. I think almost everybody is in agreement with that at this point, in that it offers 10 to the 500th possible realities, and it's sort of justifying itself anew by saying, well, you see, all those could be separate universes, but it's trying to keep alive something that shouldn't be kept alive. This is a theory that needs to be discarded. There's no evidence for all those dimensions and the other aspects of string theory, and most physicists feel that way now.
Okay. Bob, thank you. Another great talk. We have, just so you know, the Connecting Innovation Network is giving away some mini iPads. So if you've registered on at their booth out there, they'll send you an email if you've won one. In fact, somebody won one yesterday, so make sure you check with that. Bob will be signing books out front right after this talk, and again, he's doing an Ideas Night Out. Thank you very much.